So now I'm going to go over exponential function applications. So two very common types of problems that you can experience when dealing with exponential functions will be exponential growth or exponential decay. So exponential growth is an increase by a constant. So you can see this like with cell growth or population growth. Exponential decay is when you're decreasing by a constant ratio. So for example, radioactive decay may be an example of that. Could be a population too, wouldn't be so nice. So these growths or these constants could be framed in terms of either a percent change. So you're going to multiply by 1 plus some percent. So this could happen by interest rate. So if we were given 9%, it will be 1 plus 0.09. We had to convert that percentage to a decimal and then add 1 to it. Or if it were a decay, it will be 1 minus whatever it is that we were told, whatever percent. For continuous growth or decay, this is a little more straightforward. That's when we're just given a constant. So we're told that it doubles or triples or, it decays by a third. So we're given some value here. We have the constant ratio. E is a very common one in nature, and it's just a constant that represents 2.718282. So that's just like a constant you'll start to memorize just like pi. So here are just like a couple of scenarios that we can have. So let's look at some examples. So the first example is about a population growth. So a wolf population is growing exponentially. In 2011, 129 wolves were counted. By 2013, the population had reached 236 wolves. For part A, what 2 points can be used to derive an exponential equation modeling this situation? So if you notice what we were given a time and a count and another time and a count. So we were really just given 2 points. And we can decide how to model this. And I'm seeing down here, do you like T and N? So let's just say T. And to make our math a lot easier, I'm gonna let T equal years since 2011. You don't have to do that, but they didn't tell us what to do. I could always let T be like that raw number. I could let T start at 0, but in my scenario, I'm going to let T equals a year since 2011. And when I do this point right here is really 0, 129. So 129 is going to be my initial value. And since 2013 is 2 years after 2011, this will become 236. So what 2 points? I'm just going to write them down. So I can use 0 and 129 and 0. Oh, not 0. We already did that. We said it was 2. 2 and 236. And now we just need to write an equation to model the population N of wolves over time. So what I would love for you to do, since you already know how to do it, is to pause the video, see if you can come up with that equation, and then you can replay and see if we are getting the same thing. So hopefully you've given this a try, you didn't cheat. And let's see if we were able to get the same thing. So in our case, we were given the initial value, so that makes our job a little easier. So I could say N. And I'm just using N in place of f of x because we were told to. So this is the number of wolves over time. So N is equal to 129. That's our initial value. B raised to the t power. And our goal right now is to find B. And we can find B by substituting the coordinates from our other point. So 236 is equal to 129 times B raised to the second power. So we're going to get B by itself, so we're going to divide both sides by 129. And now I'm not exactly sure what that is, so I'm going to bring up my calculator and see. Okay, so when I calculate it, I see that this fraction doesn't really simplify to anything, so we don't have common terms. So what I'm going to do is just leave it alone. I do know this cancels out. And my last step is just to raise both to the 1/2 power. So I'm going to do that. So I'm going to raise this to the 1/2 power? Or is the same as the square root? This to the raised to the 1/2 power and equal to b. So since this is my final step, at this point, I can go ahead and round. So when I round, I get 1.3, and I believe 1.3, I lost the number already, 3.5. So that's the rounded number, 3.5. And I'm going to leave it at, oops, not sure what happened. So 1.35 is equal to b. So when I rewrite my equation, I'll get n is equal to 129 times 1.35 to the x power. So here, because we're constantly multiplying, you could also leave it in fraction form because I realize it's going to keep, because we round it over time, this may be a little off. But this is, in general, how you would get that answer. And we can always keep more decimal places to keep, to add to our precision. So now let's take a look at an example where we're using percentages. We're going to do a percent growth. So the fox population in a certain region has an annual growth rate of 9% per year. And the year 2012, there were 23,900 fox counted in the area. What is the fox population predicted to be in 2020? So what we're going to do is we can rewrite this. So essentially we have 1 point, and again, we could let t, or it could be x, they didn't tell us what to use. We could say t is years since 2020. I'm sorry, 2012. So in this case, our points would be 0, 23,900. And we're looking for the population when our year is, and 2020 is 8 years after 2012. So what is n when t is equal to 8? Well, in order to figure that out, we're going to need the function. So, and it gave us some information. So we know f of, or I'm not going to use f of x, we're going to use the n and t, but it's the same idea. So n is equal to our initial value, and I'm going to just write the general equation here just as a reference so you can remember what I'm doing, right? Our initial value we said was 23,900. And actually, I'm going to get rid of the comma because that could be confusing. We'll just write all the numbers together. So it's 23,900 times, and our constant ratio is the growth rate of 9% per year. So I mentioned whenever you have percentages, you'll take 1 and you add to it the decimal form or the percentage. So 9% in decimal form is 0.09. So 1 plus 0.09, or you could just put 1.09 raised to the t's power. So we have most of our function. All we really need, we were able to write it pretty quickly from the information given, as long as we just made it simple by letting t be the year since 2012. So now all we have to do is substitute our 8 in place of t in order to get our final answer. So here we're going to put n is equal to 23,900 times, and it's going to make that 1.09 raised to the 8th power. So we could just put that into our calculator, and we get that our final answer is 47,622. Now, when you put this into your calculator, you do get a decimal, but we can't have a fraction of a wolf, or I'm sorry, of a fox. So I rounded it to the nearest integer, or I just cut it off. So actually, kind of round it down in this case. So this will be our final answer. So here we took our information, we created our function, and then we substituted our year of interest or our input of interest in order to figure out the output at that time.